Hi guys, we're going to start with the chapter called mole concept. Very interesting, full of numericals and life. In this chapter, we're going to study about the 5 types of questions, right? The 5 types, the five varieties of sums. We start with the first variety, the first type, which is called Gay-Lussac's law. Now, what exactly is Gay-Lussac's law? Simple language. When the gases, which are reactants, the gaseous reactants, they react, they combine together. When they combine together, they do it in volumes. We are going to speak in terms of volumes. For example, 3 volumes of hydrogen have combined with 3 volumes of oxygen to form some volumes of water. So we are going to talk in terms of volumes. Gay-Lussac's law is applicable only for gaseous substances, not any liquid substances. No aqueous nature. The reactants and the products both should be in gaseous form. So as I said, what exactly is Gay-Lussac's law? The gaseous reactants, when they combine in volumes. And it bears a simple whole number ratio to the volumes of the products form, provided the temperature and pressure of the reactants and the products remain the same. The last phrase was very simple. Temperature and pressure is constant. When the temperature and the pressure is kept a constant, right, no changes, okay, it is said to be, we had Boyle's law and Charles' law in 9th standard. Boyle's law, temperature constant. Charles' law, pressure constant. And we used to study about the volume, the behavior of volume. So always remember, we're going to talk about the change in volumes when the temperature and pressure remain the same. All right. When we talk about the first question of my first type, so we have type 1. That's Gay-Lussac's. Gay-Lussac's law. All right. Talking about the numericals. In each type, we are going to take around 4 to 5 questions, right, in the crash course. Hoping that you will understand for the best. Right. Let's start with the first question from my side. The question is, what volume of oxygen would be required to burn completely 400 ml of acetylene? And also calculate the volume of carbon dioxide formed. All right. So we have oxygen and we have burning of acetylene. Acetylene, it is C2H2. All right. This is a hydrocarbon. Acetylene reacts with oxygen. First step is always balanced chemical reaction. Whenever any hydrocarbon reacts with excess of oxygen, we get carbon dioxide and water. This is fixed. Let's balance it. Oxygen out here are 3, 2 plus 1. It's an odd number. I don't like odd numbers. Make a 2 out here. Now, 4 hydrogens. To make a 4, you can keep a 2 out here. Fine. Till now, hydrogen is balanced. 4 carbon, you can make a 4 carbon out here. All right. And oxygen is 8 and 2, 10. To make a 10 out here, we can put a 5. So we have 2 C2H2 plus 5 O2 gives 4 CO2 plus 2 H2O. Now what we can do is, underneath the reactants, write down the volumes. What's that? Can I say 2 volumes of acetylene is used up in the reaction? So 2 vols. Underneath this 5 vols, 4 vols and 2 vols. Perfect. All right. Now I have been told 400 ml of acetylene. So the total which we have in our experiment, in a laboratory, I am performing this experiment. How much acetylene do I have? I have 400 ml, which constitutes 2 volumes. So can I say, if 2 volume is equivalent to 400 ml, 2 volume gives me 400 ml, right? I can ask myself a simple question. It will be this. 2 into what is 400? Can I say 2 into 200 is 400? In simple language, 2 volumes occupy 400 ml. So one volume, will it occupy 200 ml? Yes. I call it as a multiplicative factor. I call that. It's my own. So this 200 is a multiplicative factor. Again, I'm reiterating. 2 into what is 400? 2 into 200 is 400. So the multiplicative factor is 200. So this is going to be multiplied with 200 throughout. So we have 400 ml of moisture produced, 800 ml of carbon dioxide produced, 1000 ml of oxygen used up, and 400 ml of acetylene used up, because the complete reactants were used up to give me products. So that's my answer. My answer is 800 and 1000 ml, right? Coming to the next question. So this was my first one for you all guys. Right, let's go with the second question. The second question is 3000 cc of oxygen was burnt with 600 cc of ethane. Calculate the volume of unused oxygen. So we have ethane, which is a hydrocarbon. Ethane formula C2H6. In organic chemistry, you have studied all these things. Plus oxygen. Now obviously a hydrocarbon plus oxygen gives carbon dioxide plus water. When you balance it, this is an odd number. Let's try with a 2. So you have 4 hydrogen, problem. 4 hydrogen, you have 6 hydrogen out here. To make a 6, I can put a 3 out here, 3. But that 3 will make oxygen an odd number. Shit. So double it, double the 3. Let's make it 4. Let's make it double, 6. 6 H2O. Why am I doing this? Look at the thought. Oxygen was an odd number out there. I tried to double it, but that was not fixing my balance with hydrogen. So I just made a double of it. So I made it 6. Hydrogen is 12. Hydrogen is 12. Carbon is 4. Carbon is 4. And oxygen is 8 and 6. 6 plus 8, that's going to be 14. 7 out here. This is the balanced chemical equation. Write down in terms of walls. I have 2 walls, 7 walls, 4 walls, 6 walls. And above that, I have been told oxygen is 3000 ml and ethane is 600 ml. Now there are 2 competitive creatures out here. Here I was only given this. So it was easy. 2 into what is 400. So I got 200 as the answer to my question. But out here, there are 2 people in the arena for competition. Let's start from here. 2 into what is 600? Can I say 2 into 300? 2 into 300 makes it 600. So the multiplicative factor is going to be 300 as of now. So everything 7 into 300, 4 into 300 and 6 into 300. So this makes it 600 ml. This makes it 2100, 1200, 1800. Now please tell me one thing. How much oxygen did I have? I had with me 3000 ml, out of which 2100 is used up, because these are reactants. They are used up to give me products. So tell me one thing, all of y'all, that out of 3000 which I had, 2100 is gone out, used up. How much is left? Subtract. 900 ml of oxygen is unused. So this multiplicative factor was perfect. If I take this as the multiplicative factor, 7 into what is 3000, approximately you will get an answer which is going to be in decimals. So 7 into what is 3000? Let's calculate now. 4s are 28, 2s are, it will be 400 and something, right? So if I say 400 will be the multiplicative factor, this answer also would have been an absurd answer, because 2 into 400, 2 into that multiplicative factor, that decimal thing, would have given me something more than 800. How much do I have with me? I have only 600. How can I use 800? Are you understanding? It's very difficult to explain on the camera, yaar. If we are face to face, I can take you on a roll. Out here, listen. If this I would have started with this as my multiplicative factor. It would have been 7 into approx 400. Let's take now. It's 3000. So the multiplicative factor would have been 400. So everything would have been multiplied with 400. There you go, man. This also would have been 400. 2 into 400 is 800. I have 600 only. How can I use 800? I don't have. Where will I get it from? Hence, this is a proper multiplicative factor. So now I can say that the unused oxygen is 3000 minus 2100, which is 900 ml. Perfect. Right. Let's go with my third numerical. Oh, the nice one this is. The mixture of 10 centimeter cube of carbon monoxide, 60 centimeter cube of hydrogen and 25 centimeter cube of methane are mixed with 750 centimeter cube of air containing 20% of oxygen, and it is ignited. Calculate the composition of the resulting mixture on cooling. Underline the word on cooling, at room temperature. So we have 3 reactions involving oxygen with us. The first one is carbon monoxide. The second reaction with us is hydrogen. And the third reaction which I have with me out here is CH4, that is methane. They are all ignited with oxygen, that is O2, O2 and O2. Alright. Can I say carbon monoxide plus O2 will give me carbon dioxide? If you balance it, this is going to be 2 and a 2. H2 plus O2 gives me moisture, H2O. Balance it, 2 and 2. Any hydrocarbon plus oxygen gives carbon dioxide plus water. Right. If you balance it, oxygen is odd out here. You make it 2 to start with. 4 hydrogen, 4 hydrogen. Alright. 1 carbon, okay. 2 and 2. That's it. That's balanced for y'all. So all the 3 equations are balanced. Just underneath them, you can write down the walls. 2 wall, 1 wall, 2 walls. 2 wall, 1 wall, 2 wall. 1 volume, 2 volumes. That's what I said. Gay-Lussac is about the volumes. 2 walls. Now what is given is, I have been told 10 centimeter cube of carbon monoxide. Alright. So 2 into what? What is 10? Can I say 2 into 5? So the multiplicative factor is 5. Right. Hydrogen given to me is 60 centimeter cube. cc, cubic centimeter. 2 into what is going to be 60? Can I say 2 into 30 is going to be 60? So the multiplicative factor is 30. Methane given to me is 25 centimeter cube. 1 into what is 25? 1 into 25 is 25. So this will be 2 into 25, 1 into 25, 2 into 25. Perfect. Now after this, let's see how much we get in the first reaction. We have 10 cc of carbon monoxide, 5 cc of oxygen used up, and 10 cc of carbon dioxide formed. That's till now. In the second one, we have 60 cc of hydrogen used up, 30 cc of oxygen used up, and 60 cc of moisture obtained, formed. Alright, next one. 25 cc, right? 25 cc of what? Of methane used up. Then we have 50 out here. cc of oxygen used, 25 cc of carbon dioxide, and 50 cc of moisture. Alright, now I have been told, guys, that we have 750 cc of air. Now always remember, out of 750, 20% is oxygen and the remaining 80% is nitrogen. All the other gaseous products can be neglected, like dust particles, carbon monoxide, carbon dioxide, H2S, anything. You can neglect them. These are major components. Right. So can I say 20% of air is oxygen? So I can say 20% of the air, total air, isn't that oxygen? That's how much I have with me, guys. So oxygen with me in my hand is 150 centimeter cube. So nitrogen will obviously be 600 cc. Come on, 20% of this is air, which is 150. Out of 750, if 150 is gone, oxygen, what is left out? Nitrogen. That's 600 cc. Now tell me one thing. Out here, oxygen used in this reaction is 5. This reaction, oxygen used is 30. And this reaction, oxygen used is 50. So, all of y'all, oxygen used up is 5 plus 30 plus 50. That's going to be 85 cc of oxygen is used up. So, how much oxygen is left unused, remaining after the reaction? 150 I had, I used up 85. Damn, I have how much oxygen left with me? Isn't it 150 minus 85, which is going to be 65 centimeter cube of oxygen is unused. In my reactants, everything is used up except for oxygen. So I can say the unused oxygen is gonna be 65 cc. That's one of my answers. In the products, carbon dioxide is 10 and 25. So the total carbon dioxide formed is 35 cc. Moisture is 60 and 50. I won't speak about it. Sorry. That's the catch. Haven't I told you all that whenever the word cooling comes, this moisture turns into water, condensation. And Gay-Lussac's law, guys, is applicable only for gaseous products and reactants. Hence, I will not consider water as my product as a gaseous reactant. So, if someone asks you what is the resulting mixture, the final mixture is 65 unused oxygen, 35 carbon dioxide, and nitrogen 600, but moisture should not be written, right? So these are three sums which I have taken from Gay-Lussac's point.